Okay, good day again. So meron tayong another set of illustration para sa ating electrical system na medyo mas complex than the previous one. So here we will consider na meron tayong motor load or yung ating continuous load such as air conditioning units. So here our illustration. We will examine the lighting plan. We will split the lighting outlets into two circuits, A and B, and we will find the following. Find the maximum total load of the light outlet, yung kanyang current load, yung size ng branch circuit wire, yung rating ng overcurrent protection device or yung ating fuse, and then the size of the conduit pipe. So dito sa ating given illustration, i-subdivide na mismo na daan ang iyahang number of outlets per current circuit line. So we have circuit 1 and 2 here. So by direct counting, we have a 19 light outlets, which we will be divided into two circuits. Para sa circuit 1, 10 outlets. And then circuit 2, 9 outlets. Okay. So for the solution, by examining the lighting plan, there are 19 outlets nga. So for circuit A, letter A, circuit number 1, we have 10 outlets. So step 1, 10 lights outlets. Per outlets, di ba? From NEC, 100 watts ang rating. So we will have a total load of 1,000 watts. And to compute the current loads, for step number 2, i-divide natin yung total loads sa 220. So dito gagamitin na natin na type of service is 220. So we will have a value para sa current loads na 4.55 amperes. And then yung size ng ating circuit wire, since para sa ating lighting outlets, 15 amperes, di ba, yung minimum. So kahit na yung maliit yung ating value na na-solve, 15 amperes pa rin yung ating fuse or yung ating trip breaker. So sa 15 amperes, ang kanyang size ng wire is 2.0 mm or yung ating number 14 conductor wire. So here we use a THHN copper wire. Here pala hindi ko siya na-edit. So dapat TW na lang dito yung gagamitin natin. Kasi medyo pricey itong THHN since ang kanyang maximum temperature is 90 degrees Celsius. So medyo quality, so medyo mahal. So kung economical aspect ang ating ibabasehan, okay na yung 60 degree Celsius or yung 60 Hertz. So again, yung type of material is discretion na ng ating designer. Next, yung rating or yung value ng ating overcurrent protection. Since lighting outlet ito, lighting layout, yung ating kahit mababa yung ating computed load, ang ating gagamitin na fuse is 15 amperes. And then yung size ng conduit pipe for 2 wires na para sa live wire and ground wire, it will be safely accommodated with the use of 13 mm conduit pipe. Okay. Next is for circuit number 2, which has 9 light outlets. So medyo mas mababa yung value nito or yung ating current load. Pero since same naman sila, lighting outlets, and then yung kanyang minimum is 15 amperes, yung kanyang value is magpo-fall the same doon sa ating circuit number 1. So we will use a 2 pieces of number 14 conductor wire. Yung ating fuse is 15 amperes. And then yung size ng ating conduit pipe is 13 mm conduit pipe. Okay. So here, continue natin yung ating computation para sa convenience outlet plan. So we will examine the convenience outlet plan here with the loads from the previous activity, yung ating lighting layout plan. We will find the following. Yung load schedule natin from lights and convenience outlet, and we will draw its one-line diagram in accordance with the calculated loads. So from our illustration, given na agad ang kanyang, kumbaga na-subdivide niya na, siya na, yung designer na, ang designer na bahala kung ilang circuit, ilang number of convenience outlet per circuit. Pero nandun sa guideline natin kung we will observe good circuitry practices, kung ang ating gagamit tayo ng maximum 20 amperes na fuse, a maximum 8 convenience outlet lamang. Pero kung 15 amperes, maximum of 6 convenience outlet lamang per circuitry. So here, sa ating problem, we have the condition. Sa circuit number 3 and 4, we have 6 convenience outlets each. Circuit number 5, 1 range load. Kumbaga yung stove niya, electric stove. Now, circuit number 6, isang water heater. Circuit number 7 and 8, tig-iisang aircon unit. So we will proceed to the computation or solutions. So para sa ating circuit number 3, for the convenience outlet sa ating small appliances, we have 6 convenience outlet with 2 gang. So ito times natin yan siya kasi per gang is 180 watts. So we will have a total of 12 gang. So para makuha natin ang ating total load, i-times natin yung ating convenience outlet per gang ng 180 watts. So we will have a value or total load of 2,160 watts. And step number 2, we will compute the correct loads. We will just divide the type of service, which is 220 ang i-consider natin dito. So we will have a value of 9.82 amperes. And then, again, balik tayo sa ating circuiting guidelines. Diba? Sa ating convenience outlet, ang minimum rating ng ating fuse is 20 amperes. So kung baga, ano natin, direct observation, mas mababa yung ating computed current loads, di ba? 9.82 amperes lang. Pero since the code specify those regulations, susunod tayo. So ang gagamitin na agad natin dito is 20 ampere fuse, di ba? And then with the 20 ampere fuse, ang gagamitin natin na size ng wire is 3.5 or yung number 12 conductor wire. And then yung size ng conduit natin, again sa kanina, dun sa table natin, it will be safely accommodated sa 13 mm na size ng conduit pipe. Okay? So para sa ating circuit number 4, which is identical naman, 6 convenience outlet, so same lang sila ng computation. So we will proceed sa ating circuit number 5. So examining the power line plan for circuit number 5 for range load. Yung range load natin is it has an appliance rating of 8 kilowatts or 8,000 watts. Compute natin ang kanyang current load. So i-divide natin sa type of service na 220. We will have a 36.36 amperes. And from the NEC, since itong load na ito is non-continuous load, so i-divide natin siya, ita-times natin siya sa 80% demand factor. So magbababa yung kanyang current load into 29.09 amperes. Next, ang size ng kanyang wire. For 29.09 amperes, we will use 2 pieces for live and ground wire na 8.0 or number 8 na copper wire. Bakit siya na-fall dito? Dahil kahit na nag-demand factor tayo, binaba natin, kumbaga, 80% demand factor, ito pa rin na ating i-consider yung kanyang 100% demand factor. So, tignan natin saan siya mag-fall dun sa tables natin. So, here sa ating table 2-5, 36.36 yan, di ba? So, na-fall siya in between. So, mahulog na yan siya sa 40 agad. 40 na siya agad. So, since ang ating fuse is 40, we will use number 8 or 8.0 na size ng wire. So, that is the condition. Bakit yun ang ating nagamit? So, yun nga. Yung size ng ating fuse is 40 amperes. And then, yung size ng ating conduit pipe for 2 pieces number 8 or 8.0 conductor wire, we will use a 20 mm or 3/4 inch diameter conduit pipe. Okay, next for our circuit number 6, we have 1 unit water heater with an appliance rating of 2.5 kilowatts or 2,500 watts. So para makuha ang kayang current load, divide siya sa 220, we have a 11.36 amperes. For that, for convenience outlet, fall siya sa ating minimum na 20 amperes. So 20 amperes, we have a size, wire size na 3.5 or number 12. And then ang conduit pipe niya is size 13 mm or 1/2 inch diameter conduit pipe. Okay, next, examining the power line plan for circuit number 7 with 1 unit of aircon. Yung ating aircon, ang appliance rating is 1.5 HP. Per HP is 746. So for 1.5, we have 1,119 watts. So compute natin ang kanyang current loads. Divide natin sa 220, we have 5.09 amperes. Okay, so since iba yung ating may additional codes tayo or regulation tayo pag aircon na yung or mga high or heavy motors na yung ating i-compute or gina-consider. From the Article 6.7 of PEC, it provides that branch circuit supplying a motor shall have an ampacity not less than 125% of the full load current. So we have a full load current na 5.09. So ito times pa natin siya sa 125%, we have a value of 6.36 amperes. Okay? So yung 6.36 amperes, mahuhulog yan siya sa ating 20 amperes. Diba? Pero, para sa ating mga aircon unit, it shall be increased by 250 of the full load current of the motor. So meron tayong 5.09 times natin sa 250%, we have a 12.73 receptacle amperes from, and then from table 4-1 for continuous load, we will use 30 amperes of fuse or trip breaker. So punta tayo sa table 4-1 from the value na 12.73 receptacle amperes. Wait lang. Okay. So, balikan na natin yung ating mga circuiting guidelines, ha? So we have a 6.36 amperes. Mapapall na yan siya if ever yung regular lang tayo sa 20 amperes. Pero since yung aircon natin is under siya sa condition na isa siyang continuous load. So punta tayo dun sa ating table 4-1 for continuous load. So, yung ating na-compute na maximum load, di ba? 50, yung parang receptacle rating is nasa 12 point something. 12 point something. 12 point, okay, 12 point something yun, na matandaan. Okay, so na-fall siya dito. Na-fall din siya dito na continuous load. So 12 point something yun, 12.70 yung na-compute natin. So dito siya ma-fall. So yung ating fuse rating is 30 amperes. Okay. So thus, we will use 30 amperes fuse or trip breaker for this circuit number. So, and then next is yung ating size ng conduit pipe. So we have 3.5 or number 12 copper conductor wire. Then it is safely accommodated sa 13 mm or 1/2 inch diameter conduit pipe. Okay, last circuit number, which is number 8. We have again a aircon unit, pero ang kanyang appliance rating is 1.0 HP lamang. So, meron siyang 746 watts. So, to compute its current load, we will divide it with this type of service. We have 220. So, current loads is 3.39. But again, from Article 6.7 of TEC, we will compute the current load to 125%. So meron tayong full load current na 4.24 amperes. And then, kukunin natin yung ating fuse rating. Yung ating 3.39 or yung ating current load, ito times natin sa 2.5. So we have a 3.35 receptacle amperature. So for continuous load, we will again use 30 amperes fuse or trip breaker. And then, yung ating conductor wire is minimum 3.5 mm or number 12 conductor wire. Again, same lang siya sa kanina, circuit number 7. It will be safely accommodated with the use of 13 mm conductor pipe. So, from circuit number 1 to circuit number 8, natapos ang ating computation. So next, we compute natin yung ating service entrance. So for calculating the ampacity of the service entrance conductor, we will find the total current from 1 to circuit number 1 to 8. Pero dito sa slide na ito, consider lang natin yung circuit number 1, circuit number 6. Dahil merong certain condition or certain computation para sa ating aircon units. So from circuit number 1 and circuit number 2, we have total load of 1,900. Circuit number 3 and circuit number 4, we have total load of 4,320 watts. And from circuit number 6 to circuit number 5 and 6, we have 10,500 watts. We have a total of 16,720 watts. Next, the calculation for dwelling unit, we will apply a demand factor. So for the first 10,000 watts, we will multiply it to its 100% demand factor. So we will have a 10,000 watts. So yung remaining na 6,720 watts, we will apply it with apply. We will multiply it with the 40% demand factor. So we will have a value of 2,688 watts. Then dito na natin ipapasok yung ating aircon units. So from circuit number 7 and circuit number 8, we have a total watts of 1,865 from 1,119 plus 746. Ito na yung total niya. So sa aircon units, ang demand factor niya is 100%. So we have here 1,865 watts. So i-add natin lahat, we will have a total of 14,553 watts para sa ampacity ng ating service entrance. So para makuha ang kanyang current load ng ating service entrance, from the total natin na 14,553, plus pa tayo ng 25% doon sa ating highest motor or yung pinakamabigat na equipment or na appliance, which is aircon. So meron tayong total load ng aircon na 1,865, magta-times pa tayo ng 25% dyan. So ito na, 14,553 watts plus 25% ng ating 1,865 watts divided sa 220 volts. We have a current load na 68.27 amperes. Okay. So next, the neutral conductor or yung ating ground wire shall have an ampacity not less than 70% of the ungrounded or two trade size smaller than the live wire with from the PEC specifications. Therefore, we will use 22 mm conductor wire for our neutral line. And then, yung size ng conduit natin, paki-check sa ating table 2-9, mapufall siya sa, we will use 32 mm diameter pipe. And for our main breaker from table 4-1, we will use isang 100 ampere na fuse with 2 wire na merong volt capacity na 250 volts and 2-hole molded air circuit breaker. So bakit tayo gagamit ng 100 amps kahit na yung ating amperes is 68.27 amperes. So, di ba parang malayo masyado? Again, merong C, C, NEC regarding dyan. So, NEC comments regarding sa service entrance and main feeder, a total computed load is just 68.27 amperes. So, from table 4-2, mapupol lang siya sa 90 amperes. So yung copper wire, yung wire size is 30 mm 30 mm squared size. However, the NEC provides that if the computed load exceeds 10,000 watts, the conductor and overcurrent protection shall be rated not less than 100 amperes. So yan ang reason why. Therefore, we will use a 38 mm squared conductor wire for the main feeder and 100 amperes for the main breaker. Okay. So we already computed the circuit, every circuit line na mga load specifications. So, pwede na natin siya i-input dito sa ating load schedule. So, naturo ko na kung paano ito siya. So, ipang-input na lang, napang-compute na ninyo, napang-compute na ninyo itong mga values na ito. Paki-input na lang siya dito sa ating load schedule. Again, don't forget, minimum na magbigay kayo ng isang spare para sa future reference pa. Next, yung ating one-line diagram. So, kumbaga, meron tayong service entrance, and then dapat itong 100 na ito nandito siya sa ating meter banda. Okay? So, yung ating main breaker is 100 ampere. AF dapat ito. Bakit 80 ito? AF ito, ampere fuse. So, yung ating main breaker is 100 ampere fuse. And then dun sa ating circuit number 1, 15, di ba? So, 15 ampere fuse. Circuit number 2, 15 again. Okay. Circuit number 3, 20. Circuit number 4, 20. So, 3 and 4, 20, 20. Okay. Circuit number 5 is 40. Mali. 60 ito. 60 dapat ito. Again, 60 ito. Ay, hindi. Tama. 40. Tama. Sorry, dito pa ako nag-discuss. Okay. Circuit number 5, 40 ampere fuse. Circuit number 6, 20 ampere fuse. Circuit number 7 and 8 is 30 ampere fuse. So ito ito siya. Interchange. Sorry. So dapat sa circuit number 9, meron tayong spare na 20 ampere fuse. And then, ating ground wire or ating neutral line. So dito nagtatapos yung ating itong ating illustration. So thank you for listening and bye na muna. See you next videos. See you sa next videos natin.